Assalamualaikum, we are from Group 1. Today we would like to present our group assignment. I'm Nohani Shazwani binti Mokhtar, my matric number CA190207. I want to present on my part, which is manual calculation. From question 2, we need to find the Fourier series expansion for the signal xt given in the figure theoretically. Our frequency 40 kHz, T0 equal to 25 microsecond, tau equal to 12.5 microsecond, and omega naught equal to 80 kilopi radian per second or 251.33 milliradian per second. Using trigonometry, we find A naught by using formula and we get 1. For AN, by using formula, we get 0. Then we calculate BN. Using formula, we get BN 2 per pi n is n equal to odd and 0 is n equal to even. And lastly, we calculate xt using formula by insert the value that we already get, and this is the final answer for xt. For question 3, we use f0 from task 2, which is 40 kHz. The cut-off frequency is 4 times of the frequency input f0 given in task 3, so we get 160 kHz. Then using f cut-off formula equal to 1 divide 2 pi frc, we assume C equal to 0.1 microfarad. Then we calculate R, we get 9.95 ohm. Then to find the gain using formula gain equal 20 log 10, V out divided by V in. For V in is equal to 10 volt. And then for the XC, we get 39.79. And for V out over V in, we got 0.24. And lastly, the final answer for gain, we get negative 12.40.
Assalamualaikum warahmatullahi wabarakatuh. First of all, I want to introduce my name. My name is Muhammad Aiman Haziq bin Mazlan. My matric number is CE190187. Today, I want to present our project for subject signal. For my presentation today, I will present project for question B and C. Question B, transfer the result for the series into MATLAB, and question C is plot the signal in time domain for 5, 10 and 20 harmonic. And then this is our simulation. First, for the project is we must to do manual calculation for before we do a simulation. And for question B is the question is transfer the result for this series into MATLAB, and we just follow the manual our manual calculation, manual calculation, and then we transform it into coding, declare as a coding. This is our simulation after we do a calculation coding. And this and then we run, and then we get a answer for this is answer for our question TO and WO. And then after that, for question C, plot the signal in time domain 5, 10 and 220 harmonic. We need to plot signal for 3 types of harmonic, 5, 10 and 20. We need to make a 5 time harmonic and then run the section, and we get a graph signal for 5 harmonic. And then this is our plot for 10 harmonic. Same with the coding with question B. We just add a new coding to declare as a signal lah, for plot, to make a plot. This is our signal for harmonic 10. the different and then the last is signal for 20 harmonic. Yes, the difference between three type of harmonic is the amplitude is going bigger. 5, 10, and 20. The difference is at the amplitude, the signal of amplitude. That's all for my presentation. Thank you.
Assalamualaikum. My name is Muhammad Azad Shahmin bin Azman. For my part, I will be explain about the question of D, the comparison between time domain and frequency domain. First of all, I will be explain about the coding. As you can see here, for time domain 5 harmonic, we only have to change n to 5, and this is for our frequency, and this is our omega naught, and this is DC, and this is declared time. As you can see here, for percent is not the labeling for this coding. Okay, and for this one is how we construct the coding to figure out the graph. Okay, for the first figure one is to draw the amplitude spectrum, and second one, the figure two is to draw the phase spectrum. Okay, let's we run for look the graph for time domain 5 harmonics. Okay, this is a graph for 5 harmonic, the comparison between amplitude spectrum and phase spectrum. Okay, this is for amplitude and this one is for phase spectrum. Next, we are going to look for 10 harmonics. For 10 harmonics, the coding is same. The different only n value. As just as we want to run for this for 10 harmonic, we just change the value of n to 10. Okay, this one is a comparison between amplitude spectrum and phase spectrum for 10 harmonics. This is amplitude and this one is phase spectrum. For the next one is for 20 harmonics, the coding still same. The the different only value for n to 20. Okay, this is the coding, full coding. Okay, next we are going to run this section. Okay, this one is for 20 harmonic between amplitude spectrum and phase spectrum. Okay, that is only for question D. Okay, next I will be explain about the question 3. Construct a low pass filter as in figure 2a using software IE MATLAB with a frequency response characteristic given in figure 2b. First of all, we are build up the circuit in a Proteus software for RC low pass filter. Okay, this is our circuit for a RC low pass filter. Here we have a V in, here V out, and here is our capacitor 0.1 ohm, and here is our resistor 9.95, and we also have a oscilloscope here. Okay, next I will be continue how we make a frequency response curve in a figure 2. Okay, first of all, we are create a coding uh, to construct a low pass filter. First of all, our Fs is 40,000 kilohertz for sampling frequency. For cut off frequency, 16,000 kilohertz, and we are using a butter method to make a graph, and this is our design. The graph with a title filter frequency response, X label frequency, and Y label gain. Same with figure 2. The different only title filter frequency response without logarithmic scale. Okay. After we run, we will get this figure. This one is for filter frequency response without logarithm scale, and this one is filter frequency response. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan Faris Bizani. My metric number is CE190022. Okay, today I will explain for number 4. That was I need to analyze the output of the filter for boost test 2 and test 3 in time domain and frequency domain. Okay. First, we need to build a circuit with function generator, blockboard plotter, and oscilloscope. And we put the frequency, duty cycle, amplitude that was we use in manual calculation for function generator, and for other one we also from manual calculation 9.95 ohm, and for C1 0.1 microfarad. Okay, we need to run this. After we run this, we can open the oscilloscope and we get this graph that was we plot from this. Okay, this graph was not being filtered, and this graph has been filtered. Okay, for plot plotter, we get this graph. The graph start decrease at 80.674 kilohertz, and for the magnitude, and for the pace, this graph start decrease at 2.349 kilohertz. Okay, that's all for me. Thank you.